Assalamu alaikum. Today we will start with section 2.3 in your textbook. The title of this section is Indices and Logarithms. The objectives of this section is, at the end of this section, you should be able to first evaluate b to the power of n in the case when n is positive, negative, a whole number, or a fraction. Simplify algebraic expressions using the rules of indices. Evaluate logarithms in simple cases. Use the rules of logarithms to solve equations in which the unknown occurs as a power. We will start with the first subsection, that is 2.3.1, the index notation. Well, we know that b to the power of 2, it means that b is multiplied by itself 2 times. So b to the power of 2 is b multiplied by b. So if we multiply by b by itself 2 times, we can write it this way, b to the power of 2. This is called index notation. B to the power of 3 means we multiply b by itself 3 times, b times b times b. B to the power 4, also b times b times b times b, 4 times. B to the power of n, we have to multiply b by itself how many times? A total of n times. So if we multiply b by itself n times, this means b to the power of n. So in general, if a number m is written in this way, m equals to b to the power n, where b here is called the base, we say that b to the power n is the exponential form of m to base b. So the number m, if written in this format, m equals b index n to the power of n, we will say b to the power of n is the exponential form of m to base b. b here is called the base, and n is called either index, power, or exponent. So there are 3 names for this n. Either we call it the index, or the power, or the exponent. So again, b here is the base, n is index, or power, or exponent. And this is b to the power of n, or b to index n, is the exponential form of m. Now, if n is a negative number, then b to the power of minus n equals 1 divided by b to the power of n. So this can be inverted, and we write it in this way. We define b to the power of 0 equals 1. Always, any number raised to the power of 0 is equivalent to 1. This is a definition. Let's have this example number 1 and evaluate first 3 to the power of 2. 3 to the power of 2 means we have to multiply 3 by itself 2 times. 3 times 2. And we know 3 times 3 times 3. So 3 times 3 is 9. 4 to the power of 3. So we have to multiply 4 by itself 3 times. 4 by 4 by 4. So 4 by 4 is 16. 16 by 4 is 64. 7 to the power of 0. Any number raised to the power of 0 is 1. 5 to the power of 1 means we have to multiply 5 by itself once. So it's 5. 5 to the power of minus 1, we can write it as 1 divided by 5. Minus 2 to the power of 3 is minus 2 times minus 2 times minus 2. So if we multiply the negative signs here, minus times minus times minus is minus. 2 times 2 times 2 is 8. So the answer will be minus 8. 3 to the power of minus 4 is what? It's 1 divided by 3 to the power of 4. See, if the exponent here is negative number, we put it in the denominator. So we invert the number. So it becomes 1 divided by 3 to the power of 4. And the 3 to the power of 4 in the denominator here means we have to multiply 3 by itself 4 times. So 3 by 3 by 3 by 3, that is 1 divided by 81. Now, let's assume that n is a positive whole number. We define b to the power of 1 over n as the nth root of b. So if the number here is written in this way, b to the power 1 over n, where n is a positive number, then this is called the nth root of b. And we can write it using this is the symbol of the root. So this is the root, the nth root. See here, this label, this is the label for the root, the nth root. This might be 2, might be 3, might be 4, any positive integer. And this is b is called the radicand, which is inside the root. So b to the power of 1 over n, we call it the nth root of b, and we can write it in this form. So this means that b to the power of 1 over n is a number which, when raised to the power n, produces b. So this is to the left side of this equation. If we raise this number to the left side to the power of n, we will get b. This is the meaning of the nth root. Okay. Yeah. So if b to the power of 1 over n raised to the power n, then we will get b. Using this definition, let's have some examples here. See, in this table, we have the exponential form of the numbers, and in the second column, we have the root form of the same number. So if we have 9 to the power of half, 9 to the power of half, this is the second root of 9, the second root of 9, or we call it the square root of 9. And we write it using the symbol of the root like this, under the root 9, which is equivalent to 3, which means that if we raise 3 to the power of 2, we will get 9. Or if we raise 9 to the power half to 2, we will get 9. Another example is 8 to the power of 1 over 3. This is the cube root of 8. See here, this is the cube root of 8, which is equivalent to 2. 2 to the power of 3 equals 8. Or if we raise 8 to the power of 1 is 3, 2, 3, we will get 8. How about this? 625 to index 1 over 4. This is the fourth root of 625, which is 5, because 5 to the power of 4 is 625. These just some definitions showing the relation between the nth root and the exponent. Now, let's assume that the exponent is a general fraction of the form p over q. It's not only 1 over n, it's a fraction between two real numbers or 2 whole numbers, P over Q. So we define here B to the power P over Q as the qth root of B to the power of P. It's the qth root. See, Q here in the denominator is the qth root of what? Of B to the power of P. So B to the power of P over Q, we can write it as the qth root. See here the label or the index of the root. And inside we have B to the power of P. This means that B to the power of P over Q is a number which when raised to the power Q, we will get B to the power of P. So like this, B to the power of P over Q. If we raise it to the power of Q, we'll get B to the power of P. Don't worry about these definitions. Later on, we'll have some examples. Here, the picture will be more clearer. Okay, using this definition, then we can generate this table similar to the previous table. So 16 to the power of 3 over 4 is the fourth root of 16 to the power of 3, that is 8. Why? Because 8 to the power of 4 is 16 to the power of 3, that is 4096. Similarly, 8 to the power of 2 over 3 is the third root or the cube root of 8 squared, that is 4. Why? Because 4 to the power of 3 is 8 to the power of 2, that is 64. Here in the last example, we have 25 to the power of minus 3 by 2, which is the square root of 25 to the power of minus 3. That is 1 over 125, because 1 by 125 square is 25 to the power of minus 3. There are some rules of indices that will help us to understand the previous definitions in much better way. There are 4 rules. Rule number 1 says if we have 2 real numbers multiplied by each other like this, b to the power of m multiplied by b to the power of n. This is equivalent to b to the power of m plus n. So if we multiply 2 numbers, their bases, notice here the bases are the same, but the exponents are different, then the answer will be a real number having the same base b, and its exponent is the sum of the exponents m and n. So we add the exponents. We add the indices here. So the answer will be b to the power of m plus n. Rule number 2, if we divide 2 numbers like b to the power m divided by b to the power of n, then in this case the answer will be having the same base, that is b, and its index here is the difference between these 2 indices. It's m minus n. In both rules, these 2 numbers have the same base, that is b. Okay, number 3, b to the power m to the power n. So there are 2 indices here. Then the answer here will be b to the power of m times n. We multiply these 2 indices. We don't add them, we don't divide them, we don't minus them, we multiply them. Rule number 4, if we have inside a bracket a times b to the power of n, this is equivalent to a to the power of n multiplied by b to the power of n. So we distribute the index here to both a and b. So we will have 2 numbers, each of them having the same index, that is n. So here we have 4 rules. We have to remember them, and we have to use them in solving questions. Now let's see example number 2. Evaluate 2 index 2 times 2 index 5. Now based on rule number 1, we have first to look at the bases of the two numbers. See here, the two numbers having the same base, 2 and 2. The exponents here, the first number has an exponent of 2 and the second number has an exponent of 5. Then the answer will be having the same base, 2, and the index will be 2 plus 5. So we add the two indices here. So the answer will be 2 to the power 7. 2 to the power of 7 means we have to multiply 2 by itself 7 times. Example B, 4 to the power of 6 divided by 4 to the power of 2. Now, because this is a division operation, then the answer will have the same base 4, and its index is the difference between these two indices. So 6 minus 2. So it's 4 to 4. 4 to index 4. Means we have to multiply 4 by itself 4 times. Next, 10 to the power of 2 to the power of 3. See, there are two indices. We multiply these two indices. So the answer will be 10 to the power of 2 times 3. That is 10 to the power of 6. So we have to multiply 10 by itself 6 times. D, we have in a bracket 2 times 3, and the whole bracket is raised to the power of 4. So what shall we do with this index? We distribute it among the two numbers multiplied inside the bracket. So we will get to the power 4 multiplied by 3 to the power 4, which means that 2 has to be multiplied by itself 4 times, and then 3 has to be multiplied by itself 3 times, and we multiply the two answers. So these are some examples on the 4 rules. Well, these rules can be applied also on expressions, not only on numbers, but also on algebraic expressions. So let's see this example number 3, and we are going to simplify the following expressions. So let's see if we want to simplify the product of these two expressions, x to the power 1 over 4 multiplied by x to the power of 3 over 4. See here, the first number has a base of x, the second number has a base of x also. So the two bases are the same. Then the answer should have the same base, but the index here is the sum of the two indices. So 1 by 4 plus 3 by 4. So the addition of these two fractions, we learned this in the first part of this course. 1 by 4 plus 3 by 4 is 4 by 4, which is equivalent to 1. So the answer will be x to index 1, that is x. Example number 2, we need to simplify this expression. Well, you can see in the numerator we have x to the power of 2 multiplied by y to the power of 3. In the denominator we have x to the power of 4 multiplied by y to the power of 1. So what we will do is we divide the like terms. See here, x to the power of 2 divided by x to the power of 4. We can here use rule number 2 of the division and subtract the two indices. While y to the power of 3 divided by y, we can also subtract the two indices of y. So the answer will be like this: x to the power of 2 minus 4 multiplied by y to the power of 3 minus 1. So here we subtracted the indices of x, and here we subtracted the indices of y. So 2 minus 4 is minus 2. So x will have the index minus 2, and y will have the index of 2. So this is the answer. Okay. Next, if we have this expression, what shall we do with this index? Well, x to the power of 2 will be given index of 3, and y to the power of minus 1 over 3 will be given also the index 3. So the result will be x to the power 2 raised to the power of 3 and y to the power of minus 1 over 3 raised to the power of 3, i.e. we distributed 3 among the index 3 among the two terms. Here, x to the power 2 to the power 3, this is similar to the previous examples. We apply the third rule where we have to multiply 2 and 3. So we will get x to the power 6. And we have to multiply here minus 1 by 3 times 3, that is y to the power minus 1. So the answer will be x to index 6 times y to index minus 1. Okay, here we have some practice problems. The first one is without using your calculator, you need to evaluate these numbers. And then by using the calculator, you can confirm your answers in part 1. In these second practice problems, you need to simplify these expressions by using the rules of indices, which we learned just now. This is the first part of this section, which is about the indices. The next part, which we will consider in the coming classes, is talking about logarithms. Okay? So that's all for today. Thank you very much. I will see you in the class. Bye-bye. Assalamu alaikum.